If there was one word, or more like one phrase, to describe the current changes in our economy, I'm sure most would agree that that phrase is artificial intelligence. All over the news, all over social media, people are talking about what AI is capable of. They're starting Ponzi scheme businesses about it and worrying that AI will take over all of our jobs. How close to reality is this for engineering? Should engineers be worried about their jobs being automated? In today's video, I will answer that question, and it will provide you an idea of how safe your engineering job is from automation by AI. Before we get into it, be sure to hit the like button and the subscribe button, and stay tuned for future videos about engineering careers and how to succeed in yours. And stick around to the end, as I will not only be providing some insights as to the factors for mechanical engineers to consider for AI automation risks, but also on what we can do to maintain our job security through it. So let's compare our jobs as mechanical engineers, or what we might call more traditional types of engineers, mechanical, electrical, civil. Let's compare these to tech. So the first thing that I think we should think about here is which industries seem to be having some impact from these earlier stages, which ones not as much. But there's a lot to talk about the tech engineering and software engineering job market cooling, which some say it's because of AI and some say it's simply a correction from having hired too much during the pandemic. There may be at least some truth to both of those things. I'm not sure if it's necessarily more one than the other or mostly one or what it would be, but either way, what we could consider as mechanical engineers is that most AI models can write code pretty well. Like you can ask it, write me a React script that does this, or write me a Python script that does this, or write me a MATLAB script that does this. And at least nowadays with updated tools, it seems to do pretty well. But there's very little out there for modeling mechanical assemblies or finite element models. And we'll talk about that a little bit more later. But a lot of what AI could do now is simply know about what's going on. I have found it to be pretty accurate when I ask it questions about mechanical analysis and stuff, but there's no tools currently, at least that I know of, that you can like flawlessly model something up by just saying, model me this thing with these dimensions. There is something out there that I think is in the earlier stages that I'll get into later, but just comparing the difference between this versus writing code in a large language model, which is more straightforward that AI could do that kind of thing right now. And AI, like, we don't have the advanced AI robots that deal with all of the physical, tangible stuff at the moment. I mean, we may be getting there. But moving on to a different subject, let's talk about what's called Jevons Paradox. So this is a paradox where if AI were to make something more efficiently, and so it would become cheaper, let's say, because there's not as much cost to making it, so in that case, there would be more of that thing being bought because it would get cheaper. So this depends a lot on what the product is and what kind of problem it solves, and it gets into more complex economics and what kinds of supply-demand curves different types of products have. But I could possibly see in the case of commercial aircraft so if advanced AI robots got really good at building Boeing 737s and they did it safely and that there were no defects and everyone was confident that they were safe, and then they would be produced more cheaply because they're produced by these robots, airlines would start buying more of them because they could just use them as spares or give customers more room, make the customers happier, or they might just simply increase their number of flights. And I mean, this is definitely an outlier example. That's probably not the case in reality, because robots building aircrafts, I mean, I don't think we're anywhere near that yet, because there'd be some safety issues there that we really just need the humans to be building them. But that's a tangent. I digress. In reality, what we're saying here is just simply that in some cases, if something's going to be made more cheaply, there would likely be more of it being made. So it might not really have as much of an impact on the jobs that make those things as we would expect. And so that's why it really depends on what it is. I'm sure with like very simple types of microeconomic products, like let's say baguettes or something, just simple things like that. Like if AI robots were baking out tons of baguettes and making them cheaper, and baguettes costed 10 cents each because of that, well, a lot more people are probably going to buy baguettes because they're so cheap. And then there might be more work making sure that the AI robots are baking them correctly and such. But let's talk about, I'm just going to tell you my prediction on all this. I don't know what the future holds exactly because I don't have a crystal ball in front of me, but mechanical engineers, I think, as we are seeing so far, are going to be slower to adopt the use of AI versus the tech industry. Just like I mentioned, practicality. In some cases, there's higher stakes because it might be like physically dangerous things like bridges or aircraft that have really high safety stakes or other factors. And there may be a small decrease in the number of positions projected due to just some work being done more efficiently with AI than without it. But I think that would probably be a small decrease in my opinion. But I personally would be willing to believe Jevons Paradox applies to a lot of mechanical engineering products, because I would guess it would cause more quantity of these products for the most part to be demanded. I mean, if cars were cheaper, I think people would be buying a lot more cars, or just a lot of other things in general. But I mean, and it does have its limits. The reason I say that is because people aren't necessarily going to buy more open heart surgeries just because they're cheaper. No one really wants that unless it's absolutely necessary. But that's just why I say that it depends on what it is. But I have seen ChatGPT, Claude, Gemini, these types of LLMs. I've seen them do really well with solving college textbook mechanics problems. I've tested it out on a few problems, and I haven't really been able to find errors that it's committed. So that is a sign that AI is starting to really know its stuff and starting to become more and more free of errors in a lot of different areas. And I mean, to be fair, I'm only looking at mechanical engineering stuff because I don't have the in-depth knowledge of the medical field or any other field that I could use to really test these out. But the fact that like a niche field like mechanical analysis, that it does pretty well in that, is a sign that it must be doing well in a lot of areas. Because if anything, if there was only one thing it would be good at, it would probably be software engineering, because it's tech, the same industry. But that's not the case. Mechanical engineering is a random field that I'm seeing it start to really know its stuff in. On the other hand, I think one could argue that mechanical engineering typically does have higher stakes, since incorrect designs in a bridge or an aircraft or something could be dangerous for people. It can cause aircrafts to crash and bridges to collapse, and so people die. So I think there's going to be more hesitation to adopt this type of stuff for AI. And software errors are typically easier to test for and figure out, and they're not as costly. I mean, there are exceptions. There's like security related stuff that could be more high stakes, but for the most part, it's easier to test for errors in software that was developed by AI. It's not as costly to repair them and such. So this just reinforces the need that in more of the mechanical side, there is probably going to still be more of a need for human workers, while for things like software, I think they are less hesitant to be using AI and not seeing as high of stakes if there end up being some errors. So like I mentioned, it's not like there's zero tools out there for things like CAD and FEA that are done by AI. But the biggest example for something like this that I've seen that could potentially automate this is Mecagent. And I haven't actually used it, admittedly, but I've watched a tutorial about it, and it showed them prompting the AI model on what kinds of dimensions and what kinds of GD&T tolerances the part they want to build should have. And so it's just like a prompt, just like you would put into ChatGPT, except that you're putting it into Mecagent instead. and Mecagent is going to send you at least a first draft of the part in a CAD model, and you can tell it, no, change this or change this, blah, blah, blah. And so that's, as far as I know, that's the current extent to which we have AI tools doing CAD or FEA. I actually don't know of any FEA tools that are done by AI other than just if you go into ChatGPT or Claude and say, write me a PDF or text file or something like that for FEMAP or Nastran. And that you could use to pull in the finite element model, which I have found doesn't really work very well, actually. Maybe I need to try it again with the more recent models. But my point here is this is the extent to which I've seen mechanical engineering tools get some degree of AI input into them. Other than that, I can't really think of anything else. If you know of anything else, please leave a comment, because I would like to look into it and know about it. But more limitations of AI, let's talk about. These are the things that are actually going to protect people's jobs. So if AI really knows its concepts well and is free of a lot of errors from these concepts, which I still wouldn't even say that's true, but if it were very good at these, I think what we're currently seeing is that AI can perform tactical tasks to some extent, but it can't really perform strategic tasks. And I think this is why entry-level positions are said to be hit hard right now, particularly because the higher-level decisions typically made by mid- or senior-level engineers can't really be done by AI, at least not yet. Because if you were to think about like what would be needed for an AI model or an AI bot to be able to absorb whatever is going on in the department and in the general set of work that's going on, and be able to respond to that information with strategic tasks like what mid or senior level mechanical engineers might do, it would have to be constantly listening during meetings, equipped with triggers to help it comment on what's being said and provide input and suggestions like a human would. And it would have to do this without there being a ton of slop. It would have to know a lot of nuances, thinking like a human, of how often to respond and what to respond with. And I think like while you can ask it a lot of technical stuff and it just really knows well, it'd just be very difficult to get it to this level of being in the same way as a human. Maybe we could test that out. It's probably a good use case for trying out an experiment to see what we could build for that kind of thing for an AI bot. But even if we did make an AI bot that was very behaving much like a mid or senior level human engineer like this, it would be still difficult to assess the value of its contributions, just because we don't really know what would be like the perfect 10 out of 10 contribution that we might have from the best mechanical engineer who's a human in the world. But yeah, so it's very confusing and very convoluted to understand what's the difference between what strategically a mid or senior level engineer could have versus what a bot could provide. And I think we're just not really close to being there yet. And as far as I've seen, like I mentioned, hallucinations by chatbots aren't a huge problem as they used to be, but they do sometimes fail to capture the nuance in answering questions as they could. I have tested it out a bit and just seen like it is pretty good about recognizing if there's errors and such, but it's going to be hard to detect these errors. That's why you're going to keep needing humans for the foreseeable future to do a lot of this stuff. So I hope that helps you to understand AI and how it could potentially impact our work as mechanical engineers in the future. And in short, I think it's not a ton anytime soon. Maybe by the time most of us are done with our careers, or after most of us are done with our careers, there might be more and more. I just don't think there's a ton to worry about right now, but I would say like keep trying out ChatGPT and Claude and Gemini and such, and use it to learn new concepts in your field. and figure out ways to use it to make your job more efficient. Obviously, don't put any proprietary information for your company in it because that could get you in trouble. But use it in limited ways that you can that could actually allow you to be more efficient. I hope you found this video helpful. If you did, be sure to give it a like and subscribe, and continue to follow this channel and stay tuned for more information about how to succeed in your engineering career. Thanks for the view. Talk soon. Bye.